Today I'm going to review this brand new product from Kaiweets. It's the ST100 Multifunction Voltage Tester, like a pen type tester. So this has only just been released, it's brand new. I think only one or two other YouTubers may have even received products, I'm not quite sure. So I'm going to put this thing through its paces, we'll see what it can do. I'll put it on my calibrator, on my reference standards, all that sort of stuff, and we'll see how accurate it is and how it performs. You want an informed decision, don't you? So let's have a look at it. So pen style, it's got a obligatory QC passed sticker, serial number on the side. Runs off two AAA batteries, which has a screwed access. It's got probe leads going the end here, which won't be standard spacing. They're going to be closer than that. There's standard spacing, so yep, standard like double spacing like that won't work. But obviously they've done that because of the form factor. You can understand them doing that compromise because this is necessary for the form factor. Power it up in a minute. Leads that come with it. I'm not going to open these up. These are the standard Kaiweets leads. I've seen these with the other meters as well, exactly the same ones. These are PVC leads. Let's open it up. We need to do other tests as well. Let's open it up. So these are the standard leads that come with all these Kaiweets meters. They all look pretty much the same. Might be exactly the same leads, I'm guessing. I don't know, is that meter? Might be slightly less than a meter actually. Let's measure this. That is 800. My suspicion was correct. It's 80 centimeters long leads. Guess I figured the long ones weren't necessary for this particular job. I don't know, because these are more electrical. I suppose you don't want too much wire hanging around here. Quick look at the manual. What does it do? Turn it on off, function key, data hold, and flashlight. Smart measurement, as in auto measurement. Non-contact voltage, frequency, capacitance, diode test, live wire detection, which is also non-contact. Sometimes they do them through the lead, so you actually plug the lead in. Probe with just one cable. See if there's power there or not. Non-contact phase sequence detection. So how does it do that? Right, it does actually do phase detection somehow. It must be a timing thing, maybe. Must be a timing. So apparently you stick it into one phase first, wait for it to beep, and the display will change, and then you put it into another phase line. So I'm guessing it's timing. It must like synchronize itself and then expect a certain timing. That's clever. DC 80 volts, frequency, resistance, continuity, capacitance. Let's check it out. Let's put some batteries in. It actually came with batteries. Kaiweets seem to do that actually. They always supply batteries in the meters, which is quite a nice thing. Some other brands don't do that. That feels like a metal threaded insert. It is a metal threaded insert. Nice. Good attention to detail. Unfortunately though, the screw's not captive. Would have been nice if the screw was captive. They put like a fibre wash on the other side so it didn't just fall out the casing, or even had a shanked screw, so it's got a flat section on the screw and then the threads, so you sort of screw it into the casing initially and then it will hold itself in the casing, which, you know, it's a nice thing, but it's a little detail. But the fact you've got a metal insert in there is quite nice. Okay, let's put the batteries in. Which way around you go? It says this way, according to this case. Would be nice to put an engraving on here, but with the mouldings, it'd be side. Yeah, I can't understand why I didn't put it on the side or something like that. Would have been hard to do from the manufacturing perspective. There's easy. Oh, made a sound. Something happened. I'll actually do a teardown this as well, so make sure you stick around. So like I said, I'm going to put it on the calibrator, check all the accuracies on voltages, frequency, resistance, or actually put it on a proper calibrator and see how that goes. And so make sure you stick around for that. So non-contact voltage, this function will seem to be on right now. Somehow I've already turned it on. So turn it back off again. We'll start from the beginning. So I'll turn it on. So I've got this film on here. I'm not going to do a film pill. Not today. Sorry. So some non-contact voltage. Sometimes you can rub them, get things to work. Let's see if I can get this to trigger. Yep. Yep, that does trigger quite nicely. It's got a little LED that flashes over here. Let me find something I can actually show you. Here you go, there's an AC power cable. There you go. Here we go, it's just a 3 scaled. So it's got 3 levels of detection there for LEDs. It's got the flashing LED on the end as well. Does that make it more sensitive if you're trying to get into a socket maybe? I don't know, maybe. Oh, that seems to work alright. Next function. Auto. Auto doesn't do non-contact automatically. Okay. auto mode. Let's put some cables on this. So, original pieces that came with it. Max 10 amps, Cat 3, 600 volts with the covers on, and without them, this is Cat 2, 600 volts, which is normal because of the exposed area. I'm just going to pull those off. Bams. Yeah, there's a relay switching, I can hear that. Yeah, we need to do the manual modes to see how good the continuity is, but it works. I mean, the beeper's fairly quiet. It's also got like a display over here which shows up. It's also something it does. So this is frequency measurement. We won't see anything from that. We'll look at that later on. Capacitance. We'll look at that shortly. I'll get my standards out. You see that on display because my lighting will be drowning this out. Let me turn on my lights off. Makes it slightly better for you, but maybe a bit grainy now. I think in person it's okay. It is a little bit harder to see. Well, it might be LCD, backlit LCD I'm guessing. So that's capacitance. Here's voltage, or diode, it's diode symbol. So if I short that out now, yeah, no beep. Next one, live contact. Let's stick this into a PowerPoint and see what happens. So live contact. See that? Stick this in here. Here we go. So this is the neutral side. This is the live side. Don't touch that bit. So I'm guessing that will change with voltage. So that's high voltage. Let's drop my transformer down and reduce the voltage, and we'll see what we get down to before it changes scales. Oh, there we go. Well, that took a long way to get that to even stop. There we go. So low is at about 9 volts. And it goes to high at about 13 volts. So it's not much of a linear range here for that low voltage one, is there? I thought it'd be more like 50 volts or so for low range. But anyway, the high range one seems to work. That's fine. Next function. PA. What's that? What's PA? Ah, okay, of course, PA, phase A, and that's phase B, and phase C for doing the phase rotation thing which I talked about before. So that's what that is, measuring phases. I don't have a 3-phase supply, so I can't test that. Next mode, that's the non-contact voltage. So we've got frequency, capacitance, voltage, live contact, phase. Is there no manual resistance mode? I think you can only do resistance in auto mode. That's weird. In fact, this means you can also only do the continuity test in auto mode. And it's a bit slow. I'm not going to hook up Ian Johnson's tester for this, because it's like, I mean, it works, but usually you want to be running along a row of pins and checking for connection between pins, or checking across a circuit to find out where something's going. I would have thought we'd have separate modes for continuity and resistance. It doesn't, it's just only got the auto mode. In fact, the more I think about this, auto, it says volts, ohms and continuity, right? It didn't have a volts range either. It didn't have a separate mode for that. Now the issue I had with one of the other meters I had from Kaiweets, more of a thing you have to be aware of, is that in auto mode it wouldn't actually register voltage until it got to about half a volt. So we need to test that function. If you like multimeter review videos, make sure you click on like and subscribe, because I've got a big playlist of multimeter videos. Well, I'm doing all these reviews. Every time I review a multimeter, I'm putting in this playlist. So if you're looking for a multimeter and you're not sure which one to buy or what suits your needs, check out my review list. You know, there's loads in there, and it's just going to keep on growing. So yeah, anyway, this is Ian Johnston's PDVS2 Mini, which is a 10 volt or 0 to 10 volt accurate voltage reference. See your digits there? It actually means it. This is way more accurate than this will be. Anyway, we'll shove those in there like that. I could use a probe, but you know, anyway. So that's currently showing as a short at 0 volts. Still 100 millivolts, 1.1k. That's not quite right. You can see I'm not doing resistance, can't you? So 100 millivolts, and it says we're doing 1.1k. 200 millivolts, 3k. Do you see a problem here? It says mega ohm, 400 millivolts is mega ohms. 0.5 volts, there we go, there's that DC step. So that's exactly the same thing as I found with the other Kaiweets meter. Was it the ST600Y, was it? Was that the one I was thinking of? It didn't actually detect voltage until at least half a volt. But if you're doing low voltage stuff, you might need to be careful about that. Anyway, so yes, and it's out by 1 millivolt, 1 count, which is, I'm sure it's in spec. I haven't looked at what the spec was. I'm sure that's fine. Let's go to 1 volt. 2 counts out. Okay, let's do 2 volts. I want to see where this thing rearranges. 2 volts. It's 5 counts out. 3, 5. There we go, it rearranged there. So 4,000, is it? Looks like it might be a 4,000 count. It will say so in the manual, but I haven't read that. I don't read manuals. There we go, 4.3, so it must have like an overrange of 2 or something. But it is a bit slow to respond. You can see how that response is. You know, that's not fast. Yeah. And there we go, back to that again. Sorry, Kaiweets, not impressed so far. Let's check capacitance accuracy, shall we? So I'll leave on auto range for now. I don't think auto range will work on it though, because it's got a dedicated capacitance range. No, so I have to go to capacitance range individually, which I think is fine anyway, really. So, we'll start off with the small one, 200 picofarads. I'm sorry, these leads, because these are PVC leads, you can see the hassle these have, eh? Alright? This is why I'm not a fan of PVC leads. I mean, silicon leads do cost more. They are more expensive, because the processed silicon is a thermoset plastic, not a thermoplastic plastic. You know what I mean? And so it's a different chemical process, now more expensive to make. So this is a 200 picofarad cap, and it's actually measuring it. 210 it's giving us. That's alright. So let's do 1 nanofarad. Okay, but it's measuring it too, but it's out by 25 counts or so. 20 nanofarad. That's out by, what, 19 counts, but it's measuring it fine. And 1 microfarad. That's almost perfect. It's only 1 count out. That's good. So capacitance seems okay. So I've got this 15,000 microfarad capacitor out. Let's stick this on and see how this behaves. Can I read it? Might take a minute because it's a big cap. It's got to charge it up and stuff. Oh well, really? You try turning it around the other way. Sometimes that can make a difference, believe it or not. That's interesting, isn't it? So if you put it on backwards, it can read it just fine. It's 14.7 millifarad, so it can read it. But when I put it on the other way around, which is the correct way around, the correct polarity, it couldn't read it. Let's do this again. Now it can read it. Strange. But it is a pretty big cap for these things to read, so it can read it. That's alright. So it looks like other things it's got on here. It's got obviously a hold function, which is what the H means. It's also got a torch. It does. It's got a little illumination LED. That could be handy if you're working in a panel or something and you're trying to probe something around. Or, I don't know. I mean, it has its uses. Right, it's going to take us a step further. Let's go and take this thing to the calibrator. So, to the calibrator. So here we are at the calibrator, and I'm already facing some challenges here. First thing is trying to get the display so you can read it. Now the angle on the display downwards is really good, like they did on the other meters. If it's laying flat on the bench like that, you can read the display from really low angles. It's really good, like even here, that's a really good angle. If I try and hold this up so it's with the camera, in line with the camera, the display basically disappears. You can see that, can't you? So it gets darker and just like that, you can't really see it, can you? That angle's awful. So it's got a really good low angle, all the way down. I can read that all the way down. But upwards, rubbish. I'm facing some challenges here, even just getting it so you can see it. So the lowest range I can do on this thing will be 1 volt. So I'll put it 100 millivolts just to prove it, I suppose. We'll turn this on. This is on DC volts, 100 millivolts. And we'll turn the output on. And it thinks it's resistance again. I mean, this is the problem. I need to kind of prop this up somehow. This is just annoying. Anyway, so yeah, can't do that. 1 volt, yeah, it got there, and as you saw before, it's a little bit out, a couple of counts. Right, I found some way of wedging it up. It's not ideal, but it will do the job. Right, so yeah, 1 volt, yeah, it's there. Can I go down 100 millivolts now? Or let's see, work our way downwards actually. Would it drop down to resistance? No, it's still measuring. Okay, that's good. Yeah, there we go. So you can't measure below 300 millivolts on this thing, and then you have to start a higher voltage and come downwards. I think that's pretty useless, really. I don't like the auto mode. Let's do 10 volts. There's 10 volts. It's a couple of counts out, and it's a bit slow to get there. 100 volts. I think it's rated for 600. It got there eventually. 1 count out. That's 100 millivolts. You know, it's not a big display. 3.5 digits. It's right, but it's a bit slow. Okay, let's go down to say 200 volts. Turn it back on. Took a little while to get there. 300, 400, 500, overload. Okay, so oh no, I did go 500. Did get there. I thought 400 was going to be the limit then. It's 500. 600, there we go. Now it's warning it's dangerous. Shouldn't that go off at about 200 or 150 or something? Even 100 volts? I mean, that's the max, obviously. Yeah, 700 then doesn't like that. It's a bit slow. So I've got an AC, no output, 1 kilohertz, and it's seeing as a resistance. I'm going to try and do 100 millivolts anyway, we'll see what happens. No, that's resistance. That's pretty useless really, isn't it? 1 volt. 3 counts out, that's alright. 10 volts. 5 counts out, yeah, it's alright. 100 volts. 100 volts. Yeah, it's okay, 4 counts out. A little bit slow to get there. Let's crank up a bit. Volts, yep. 8 counts out. 416 counts out. 500 is 2 counts out when it rearranged. Interesting. Let's check the frequency response out. So we're at 1 kilohertz right now, 1 volt. Let's go down to 100 hertz. That shouldn't be a problem for it. Yep, that's fine. 3 counts high. Let's go down to 50 hertz. 1 count high. Alright, let's go 5 kilohertz. Oh, it's not liking that. Okay. 2 kilohertz. Yeah, it's reading it, but it's getting quite far off there. So it looks like 1 kilohertz might actually be the limit of what this can actually measure. Okay. Alright, let's check some other functions out, shall we? I'll come back and do resistance in a second. I just want to do that frequency. Here we go. 1 kilohertz. 1 count out. 10 kilohertz. 1 count out. 100 kilohertz is 1 count out. 1 megahertz is perfect. It's actually doing alright for frequency. Let's go right down the bottom end, see what we can do there. So 100 hertz, it can measure properly. 40, yeah, no problem there. The frequency actually responds quite quickly. I think it's just the auto mode which is what makes it slow. If you're not in auto mode, it's a lot faster. The 20 hertz is fine. 10 hertz. Yeah, that's doing alright. So auto mode is what's slow on this thing. The other modes look like they're alright. Alright, so I'm now in resistance mode. This is set back to auto. Let's turn the output on. Outputting 10.4 ohms, we're getting 10.3, 10.2, 10.1. It's floating around a bit. It could be a bit of noise, maybe. No, I think it's just floating around a little bit. It's probably the auto mode thing. It's got one range. So 100 ohms is only 1 count out. That's more stable. 1k, 5 counts out. 10k is 5 counts out. 100k is 5 counts out. 1 meg is 4 counts out. 10 meg is 4 counts out. 100 meg cannot be read. Time to do a teardown, I guess. Right, let's pull this thing apart and see what's inside it. Those are plastic screws, but it does no harm in those ones being plastic screws because you shouldn't really have to pull it apart anyway. QC pass sticker, yeah, it's got to come off, hasn't it? Can't leave that on there. How's that go? Does that lift up? I think it does just lift up. Yes, it does. Okay, so the battery holder is actually a separate piece which is screwed in. That's interesting. I was sort of thinking that they could have maybe moulded that in, but actually, no. Well, actually, they could have done. They could have been moulded in if they'd done the back differently. But anyway, never mind. This is an interesting insides. Zoom in. Enhance. Oh no, that's wrong. There's the beeper, which isn't that loud. No cover on it, so you can't make it louder. Got some MELF resistors over here. Blob chip. Looks like some kind of converter over here. Interface connection. Look like transistors because the motor's Q. There ain't much to see in here, is there? Where's the fuses? Where's, well, any kind of protection really. Just set the board out in case it's on the back. Looks like it's 4 screws. There we go, the whole thing comes out the housing like that. Let's drop the screws off. Here we go, there's some protection. There is some in there. And there's that little relay we could hear clicking. Bit of flux residue around there though, look at that, it's not been cleaned off. And that soldering's not the best, look, there's like no solder on the top side for that device. The bottom side's okay, but you shouldn't really solder both sides. Okay, well, it's got some PTCs in there. And a relay. There's a couple of little parts up there, what's that, transistor? Yeah. There's like nothing to this thing really, is there? Obviously got the display of the backlighting there. Which is falling out, see that? Sliding out from the inside. LED display section. Pop off. It does pop off. There's the LEDs. Zebra strip connection to the display, so I should probably be more careful about the thing not falling off. But there's nothing to it, is there? I mean, I don't know. There's a couple of PTCs. It's not great. There's no fuses, but then the PTC, I suppose, did the job. But this is kind of targeting more industrial kind of action, you know, like doing high voltage stuff. These kinds of probes are what meant for, you know, targeting high voltage stuff. And to be honest, I wouldn't be using this on high voltage. Blast protection is practically non-existent. We got some PTCs. Clearances aren't great. Not great soldering. flux residue. Sorry Kaiweets, I'm not happy with this thing. I'm not impressed by this one. I shall put it back together. Don't forget to click like and subscribe. My summary of this thing. I think if you're a hobbyist and you're not in a hurry and you're not worried about measuring below 500 millivolts, this might be okay for you. If you want to do anything above 100 volts, I'd say no. I don't think this is really suitable for that. It's got this cap rating on here, but I don't really agree with it. I mean, there is input protection there, there is a couple of PDCs, but I'm not really seeing much there, like blast protection and stuff like that. I mean, if you're sticking this on a high voltage line, then if you get a surge come through and it blows, there's almost no blast protection around here. I mean, you only got the sides which are interlocking slightly. I don't recommend it for high voltage stuff. If you're a hobbyist doing some bench work, or you just want something small and portable you can carry around or put in your glove box of your car, maybe, it might be okay for that. Non-contact works quite well, that's quite good. Yeah, I don't like the auto mode. The auto mode's way too slow. The fact you can't manually select the mode is a issue for me. I think if you could go through the modes manually and manually choose voltage, like on the other meters, which might even be the same chipset, I don't know. Those ones you could actually do it much quicker. The measurements would be much faster if you could set the mode manually. They worked a lot better. The auto mode I wasn't happy with in the other meters either. Yeah, I'm not happy with the auto mode on this. I don't know. If you're a hobbyist, it might be okay for you if you're not expecting too much. If you're more professional, I'd say this isn't going to be suitable to you. Anyway, thanks Kaiweets for sending it to me. I do appreciate the support by you sending me products. Unfortunately, I'm not impressed by this one. Sorry guys. But hey, I don't even know what these things are worth. I've got no idea what the price is. There'll be links down below to their Amazon store actually. Yes, Kaiweets have supplied me links for the Amazon store. You better go for those links and have a look, a bit more detail, maybe some, maybe download the manual and stuff like that maybe, and find out some information. Obviously find out a price. I expected better things, to be honest. Thanks for watching. Check out my review videos in the playlist down here. Subscribe here if you're not already subscribed. Patreon support link over there if you want to help me to buy things for mailbag and repairs and stuff like that. And there's a playlist YouTube things you should watch. Bye.